Let's see. So, day 6, lanternfish. The seafloor is getting steeper. Maybe the sleigh keys get carried this way. A massive school of glowing lanternfish swims past. They must spawn quickly to reach such large numbers. Maybe exponentially quickly. You should model their growth rate just to be sure. Although you know nothing about this specific species of lanternfish, you make some guesses about their attributes. Surely each lanternfish creates a new lanternfish once every 7 days. However, this process isn't necessarily synchronized between every lanternfish. One lanternfish might have 2 days left until it creates another lanternfish, where another might have 4. So you can model each fish as a single number that represents the number of days until it creates a new lanternfish. Furthermore, the reason a new lanternfish would surely need slightly longer before it's capable of producing more lanternfish, 2 more days for its first cycle. Okay, so we have 7 days, every 7 days except for the first time it's 2, and then there's an offset when it can go next. Okay, so suppose you have a lanternfish with an internal timer of 3. After 1 day it would become 2, 1 and 0. Okay, after another day its internal timer would reset to 6 and it would create a new lanternfish with an internal timer of 8. Okay. Oh yeah, because it's 0 base, right? Okay. So 6 means 7 and plus 2, yeah, okay. After another day, the first lanternfish would have an internal timer of 5 and the second would have a timer of 7, etc. Okay. A lanternfish that creates a new fish resets its timer to 6, not 7, because 0 is included as a valid timer number. Yeah, we saw that already. The new lanternfish starts with an internal timer of 8. It does not start counting until the next day. Realizing what you're trying to do, the submarine automatically produces a list of the age of several hundred nearby lanternfish, your puzzle input. For example, suppose we were giving the following list. Okay, this list means that the first fish has an internal timer of 3, etc, etc, etc. Yeah. Let's see, in this example, after 18 days there are a total of 26 fish. Yeah, okay. Find a way to simulate lanternfish. How many lanternfish would there be after 80 days? Okay. So the trick here would be to just keep track of how many you have for each countdown per day. So you don't want to track individual lanternfish, because that would be it just grows and grows and grows and grows. So you probably want to have like a dictionary with the key of how many days, and then you have how many fish have that day. So I think that would just be it. I think this is fairly easy, but those are usually famous last words. So let's get coding. Yeah, so it should be one line, the input. Let's just check the input. One long line with numbers, right? Okay, this is word wrapped, so that is fine. So we do as int 32s. Those are the lines. And actually, we will probably make this into a dictionary. Group by x to dictionary. X is also the key. Okay, so we have our fishies is this, and now we have a dictionary of all our distinctive values. So we simulate 80 days, right? So we do int days is 80, we do int, no, for int day is 0, day smaller than days day. So this is just 80 loops. And now we do for each int counter in fishies dot keys. Let's see how it works, because when it a 0 becomes a 6 and adds a new 8, just decreases by 1. Okay. So we actually need to order by descending. To list. So we take the oldest one and we all shift them down. No, actually we don't. We go up, but we don't do the 8s. Let me see. That's a good one, because we need to... Okay, so I'm just thinking, if we do this loop in reverse, then we can decrement them. I just thought about why that would be an issue. Let's see. Oh yeah, because you add the new ones and then those are part of the next step. So you don't want that. You want to increase them going up, but you don't want to add the new ones for 0. So let's see. Because 0 is a special case and we want to add them later. So we will skip that one. So we order by right, okay. So if counter is 0, continue. Or we can do now int at day 8 is 0. Any zeros should not be present because they should always just reset. So we do if counter is 1, new value becomes 0, but we change it to 6 instead. Ah, this is also an issue. Let's see. Reset count is 0. So if this is 1, we can do reset count is fishies keys 1. No, just 1 like this, and then we can actually remove this list. Come on, dot remove, because this will become 0, and afterwards we add them here. So we do if reset count larger than 0. We do fishies can do try add actually. Doesn't that have like an overview where you can... No, okay. If fishies try get value 6 out existing we can do let's see, fishies 6 is so we just add them if it doesn't plus reset count, and we do the same for level 8 here. Okay, so that is that, and else we do, actually it's always just the same idea, so I can probably turn it into an action. So we can do action int add to, you can just call it add is day, we need two values actually, day amount. Now we can do here fishies, try get value day plus amount. Like that. Okay, so we can say this becomes add 6 comma reset count, and this one becomes 8. This one becomes add counter minus 1, and then we have fishies counter. Okay, so this should be it. And after, how many lanternfish would there be after 80 days? Okay, so this will be the sum of all all entries in the dictionary. So this will be int sum. Actually, let's make it a long. Sum is fishies dot sum. Value. And there's probably a way to simulate this, to not have to go through each day, because there is a certain pattern here that you can predict. But let's just run it this way for now. Boom, input string was not in the correct format. It's actually a single line. I need to split like this. See, it resulted in an overflow. That's why I wanted to have the long. And there is isn't there like a sum long? Let's just do it like this. Sum is 0 for each var entry in fishies. Sum plus equals entry dot value. This I actually. Let's make sure that this one is. Long count, so it's a different type. Okay, that should be good. Reset count here will also be a long now. That's a very big number. I wonder if that's correct. Not the right answer, too high. Woo! Okay, let's see. For our fishies equals this, like that. Let's just see what it does. Because fishies, it should have 4 entries. Right, okay. After 1 day, yeah, sure. Let's see. After 18 days, okay. So probably, if this runs, what will it become? Okay, it just does crazy things. Let me see. I never remove. That's not so smart. Okay. So the reason why this didn't work is because I didn't remove the entry here. So I just need to do this. And now it should give me 17,000 is still not correct, I think. Let's just print it out every day and see where it goes wrong. Day. So we can just reset some here and just declare it up here. And do the same here. And let's just set it like it should be because it's a long. I need to have a format in here. So let's run that again. That's interesting because for day 0 it already has 6 entries while it should be 5, right? Let's see. After 1 day, here it is. After another day it would be 0. After it's 0, then it triggers. Okay. So from 0 it goes to 6. So this should be if counter is 0. And actually it should process it when it, yeah, okay, right, this is correct, okay. So that is another step, 5934, 5934, okay. See, it's all in the details. One tiny little mistake and it's not making any sense anymore. That's why it's really good to have some test input there. Boom, right answer. Okay, that was nice. Part 2. Hey, Lonely Fox, thank you for joining me. I'm just doing Advent of Code and having lots of fun and bugs, as always. So if you want to join along, those are the links. I have a playlist for every day of this year, and I have a playlist for a lot of days from last year. So let's see. Suppose the lanternfish lives forever and have unlimited food and space. Would they take over the entire ocean? After 256 days, in the example above, there would be a total of a lot of fish. How many lanternfish would there be after 265 days? Okay, so it's the same. And this comes down to how you code this up, right? Because if you don't do it as I did right here, you run into like mega long lists. Because if you treat each one of these fish individually, you'll make your computer spit all over itself. So days becomes 256. And this is part 2. Boom, done. So yeah, this is one of those things, if you know what to look for and what kind of troubles you can have, it's really easy to solve the part 2. So if we go back to this issue, what a lot of people might want to do is just keep a list of each fish with their value, and then after it hits 0, you add a new entry for an individual fish. Yep, I'm also doing day 6. Yeah, I can't figure out how to make part 2 solution run fast enough. Well, I just gave you the spoiler if you don't mind it. So what I did was I put all the fish into a dictionary. So instead of treating each fish as a unique fish, I just look at which day they are in their stage. So I just have, if I run it here, I can show you. So I have my fishies here. And this is basically a key value pair of which day in their cycle there are and how many of those fish that we have. So for the initial input, you have 42 fish with day 3, 36 with day 5, 112 with day 1, 50 with day 4, and 60 with day 2. So if you treat them like this and just keep running totals, you should be fine. And the tricky part is that you have to remember some stuff while processing. So you need to process them from lowest number to highest, because you decrement them. So if you don't do that, you add to a list that's not ready yet. So you have to do double bookkeeping, or just do it as I did here. So go from lowest to highest. But also the special case of counter 0, you need to do that after the whole loop is done, because otherwise you would process them as you go along. So what I do here is, if there's a amount of fish that are ready to create new ones, so index 0, I just keep track of that number and I delete them anyways. For the other ones, I increment the previous number. So if there's 1 or higher, I just add them to the existing number that we have here. So let's see. In this example, so you do process number 1 first, that becomes a 0 with 112. And each of these just shift down like this. It's just until you get to a new one that you start adding them up. How did you like Advent of Code this far? I must say that I really like the challenges. This one was kind of easy, but yeah, I spent most of my time usually writing code to format and read the files. So I've been writing all sorts of extension functions by now. So for instance, I wrote this class for the vents yesterday, and I have all sorts of helper functions, like the split by gives me just a helper to split by any arbitrary sequence of characters. And now I have added a as value tuple, because yesterday you have these pairs of integers, and it was like XY coordinates. And I really like to have it parsed, like in this case you have an XY from and an XY to. So I have all these helper function that makes me format this like that. So I added, after yesterday's stream, I added a function called as value tuple, which just takes an IEnumerable and it expects at least 2. Yeah, I got the €0 bills on the wall. They are pretty cool. My wife gave them to me as a gift a while ago. It's pretty funny. If you Google them, there's actually a guy on YouTube that made like a whole story about all of those. There are so many of those, by the way, but they're real bills. But it's a really weird thing. There's somebody that collects them, but it's an interesting video. You should Google it. So yeah, back to my helper function for yesterday. Because I wrote it like this, and I had, an array with indexed. It just looks a bit nasty like this. And I was like, okay, maybe I can write a helper function to do that. So I made this as value tuple that just takes an IEnumerable of something and converts it into a value tuple of 2 of the same types. And that allows me to convert them like this. So I can parse actually the entire string in the way that I want it. And internally, you can map any value tuple to a named value tuple like this. So the code becomes a little bit more readable. So you can just have dot from and to properties here. So yeah, I really like that. I've been expanding this helper stuff, and it's really, it's not that complicated, but it really helps to like go through the tedious stuff, like splitting a new line, removing empty entries, etc. You always type the same stuff, so I just have a dot to lines on a string extension. Same for like as in 32s. If your input is an array of strings and they are all ints that need to be parsed, so you can just do dot as in 32s and just leave out all the boilerplate code to do that. So yeah, I really like that. So yeah, that was today's stream. It's a bit short, and I see people coming in to watch, but yeah, it's done already. So I'm going to work more on my NFT swap that I'm building, but I'll do that off stream. It works better when I'm not streaming. So I want to thank everybody for joining. What's this program going to do? Okay, let me just quickly explain. This is Advent of Code, and this is just like a yearly challenge. And let me show the calendar here. So every day from December 1st to December 25th, there are 2 programming challenges that open up, a part 1 and a part 2. Part 2 opens up after you complete part 1. And it's just a big fun challenge, and it always unlocks at the same time, and there's like a leaderboard for top 100 people. So this is the leaderboard, and it's like a speed contest. I don't do it for speed because I stream it like a few hours before the next one opens up, I think. Right? If I look at the calendar, the next one starts in 9 hours, so I start really late, but I decided to just do it when I can and not work my schedule around it, because I don't really have time to do that. So it's just a fun challenge, and there are previous years. I don't even know, how can I list them again? The events. So there are previous years that you can go back and do, and I'm just having a lot of fun doing these programming challenges. The fun thing is that they start really easy, so basically everybody, even with very little programming experience, can do these challenges, and they get progressively harder as you go along. But yeah, it's just really nice, and even more experienced programmers use them to like set challenges for themselves, learn new languages. There is a guy that used to rank very high in the leaderboard every day. And I can really recommend his stuff. He was one of the faster guys in the previous years, and he's actually doing it in Temple OS this year, which is a bit of a challenge. So that's a from scratch operating system. The programming language is there is Holy C, and he has set a challenge for himself to do this Advent of Code this year in Temple OS in Holy C, and it's a lot of fun. He's a lot more skilled at this than I am, but yeah, it's just really cool. Usually when I do this before I go to bed, I just go to YouTube and check the challenge of the day to see how other people tackle it. It's like today's challenge. The tricky part here, as the Lonely Fox found out, is that you don't want to treat each of these as individuals, but you want to treat them grouped by their stats. And so that's something you learn. When you try to tackle this problem, you run into something that it just won't execute within a fair time. And you're like, okay, what can I do to improve this? And that's also part of the fun. Holy C has been set to be C+, yeah. Yeah, it's fun. I really enjoy doing these things, and so far it's been really easy. I made some stupid mistakes in the past days that caused me some time to debug, etc. But it's still really very doable and fun to do. So yeah, I want to thank everybody for hanging out. I'm going to wrap it up. I'll be streaming again tomorrow unless something happens, but I think I'll find time in the evening probably. So if you like this, check out the website. Maybe try the challenge yourself, and come say hi to me again tomorrow. So thank you, and bye-bye.